Hi everybody. Today we're going to be going over a concept in chemistry which is called percent composition. So percent composition is looking at the percent by mass of each element in a compound. So if we look at a compound and we look at its formula, what is the percent of oxygen or percent nitrogen or percent phosphorus or whatever in comparison to the entire mass of the whole compound? So as a result of this lesson, you should be able to calculate molar mass. We've done this before. This was from our previous set of notes that we did the previous day. And then we are going to use that molar mass and that calculation that we did in order to find percent composition. And it's actually quite easy. So how do you do it? First, you start by finding the molar mass of that particular compound. So let's say we're looking at what's called propanol. So propanol is rubbing alcohol. This is C3H7OH. So if I look at the breakdown of how heavy this particular item is, this particular propanol, I have carbons and hydrogens and oxygens. And specifically, I have 3 carbons, I have 1 oxygen, and I have 8 hydrogens. So remember, I have the 7 coming from here, and then another 1 coming from there. So I'm going to add this up doing molar mass just like I would do before. So 12 times 3 is 36, 1 times 8 is 8, and then 16 times 1 is 16. So altogether, the molar mass of propanol, 60.033 grams per 1 mole. Perfect. So we know how to do that. So how do we actually use this then to find percent composition? The mass of carbon that it's contributing. So remember, I'm just getting that number directly from here. So I'm just going to highlight these values because these are going to be useful to us. Okay. So by mass, the carbon is contributing 30 here on this previous slide. So for hydrogen came from that previous slide. So now what we're going to do is we're going to use this formula. The percent by mass is the mass of the element from that compound divided by the total molar mass. So if we look at our previous example that we just did, we had propanol, which was C3H7OH, and its molar mass was equal to 60.033 grams per mole. So if I wanted to find the percent of carbon, what I would do is take, since there's 3 of them, that equals 36, so 6 grams to this overall molar mass. So we take 36 divided by 60.033, and we're going to multiply that value by 100. And again, I'm just using this formula that's provided for me here. We find when we put this in our calculator and equal it out, that it is equal to 60%. So 60% by mass is carbon. So carbon is providing 60% of the mass of propanol. The way we would do the percent of hydrogen, again, we're taking that number, that hydrogen, it would be 8, divided by that total molar mass times 100, would give us 13.3% by mass. I'm not going to write out the rest of hydrogen. And then I'm going to do the percent of oxygen just the same way. I'm going to take the oxygen's mass, I'm going to divide it by 60.033 and multiply that by 100, which is equal to 26.7%. All of these values should always equal 100% altogether. If they didn't, you might have a math error somewhere that we need to find. So let's try another example. Here we're going to be looking at calcium phosphate. So calcium phosphate is a pretty hefty compound. So we have calcium, we have phosphorus, and we have oxygen. There are 3 calciums, 2 phosphoruses, and 8 oxygens present. So I'm going to figure out what the total molar mass is first. It's always going to be my first step. Calcium is 40.078, and there are 3 of them, which is equal to 120.234. Phosphorus is 30.97. There's 2 of them, which is equal to 61.94. And oxygen is 16. There's 8 of them, which is equal to 128. So altogether, the molar mass is 310.174 grams per mole. So then what I'm going to do to find the percent of calcium is I'm going to take how much the calcium weighed with the 3 of them, divide that by 310.174, the total molar mass, and multiply this by 100. This is going to equal 38.76%. I'm going to do the same thing for the percent of phosphorus. I'm going to take that 61.94, divide it by the total molar mass, and multiply that by 100. Here we find that this is 19.97%. And then my final one is going to be oxygen. Excuse me for kind of writing over this, but the percent of oxygen is going to be 128, which again is from up here, divided by 310.174 times 100. Our answer then is 41.27%. Altogether, these add up to 100%, which means that I did this correctly. So that is how you would find the percent composition of, in this case, calcium phosphate. Let's do one more together just to make sure that we are on the same page. It's a little bit easier this time because we have dinitrogen pentoxide. So here we've got the nitrogen and we've got the oxygen. There's 2 nitrogens, 5 oxygens, so 14.0067 times 2, and 16 times 5, 80. Altogether, these add up to 108 grams per mole. So if I want to take the percent nitrogen, I'm going to take however heavy the nitrogens were from up here. I'm going to divide that by the overall molar mass, multiply that value by 100. This then gives us 26%. I'm going to do the same thing for the oxygen, 80 over 108 times 100, which equals 74%. And again, these values add up to equal 100. So that's how we calculate percent composition. By now, you should be able to calculate the molar mass, and now you can use that molar mass to determine percent composition. If you have any questions, please let me know. But otherwise, just get some practice done with these.